Okay, we had covered lists, and now we're going to cover another way of collecting data in many languages, and this is how we do it in Python. It's how we deal with unique values and mappings of values, sets and dictionaries. So we use a set to store unique values. We create it with open curly brackets, or we can use the set keyword. So here, let's create a set of primes using this literal syntax. And just to indicate that we can do things the same way with the set keyword, we can create a set from, say, a list of these numbers, and it will be the same thing. Okay, and we can see Python's representation of it when printing is this curly brace syntax. So is 3 prime? Well, we can ask if the number 3 is in primes. This tests set membership. True. We can do this if primes was a list, but it's much more efficient when you're testing for membership to use a set data structure. Is 9 in primes? No. Okay, now let's deal with set operations of intersection and union in Python. So if we have odds, we'll make it the set of the numbers 5, 3, 5, 7, and 9. And the intersection will be odds and primes. This is the intersection of odds in our prime set. There we go. And the union is symbolized by this pipe operator. So the union of the sets odds and primes is this set. Now sets are mutable, so you can change what's in them, but they only store unique values. So if we say to primes add number 11, that doesn't return anything, it's an operation, but then we can print out primes and we can see that it has an 11 to it. In addition, we can discard from the set, and let's go ahead and examine primes after that. So we've discarded 7. And we can go ahead and add 11 again. But because it's a set, we don't see 11 appear twice. Now sets are unordered. Values are stored by hashing, which is intentionally as random as possible. So let's see, if I have a set of names, Darwin, Newton, and Turing, I can enumerate through these with a for loop. So for name and names, I want to print the name. We can see these are out of order, and that's not quite correct to say because there is no order with sets. But we do get all of them when we enumerate, and that's the important thing. Okay, on to dictionaries. We use dictionaries to store key value pairs, or equivalently to store extra information associated with each element of a set. So let's do a dictionary of birthdays. Newton, 1602. Darwin, 1809. And we can print birthdays at index Newton. Similar to list syntax, but our indices are not integers, they are our keys in our set. Now let's try to change things, just like we can do with lists. We can mutate the dictionary. So let's set the birthday of Turing to be 1612. No, that's not right. That's not right at all. Let's change that to 1912. That's much better. So you could see that we could quickly add to a dictionary by just typing in the value of the key that wasn't in the dictionary before, and we can also change things that are already in there. Okay, and just like sets, dictionaries store keys by hashing, which is as random as possible. So it's only an accident here that the display of the keys are in order. Okay, set values and dictionary keys must be immutable. You cannot be able to change them. Not only can you not change them, you can't be able to change them, because changing them after insertion would leave data in the wrong place. So we can use a tuple for multi-valued keys. Tuple is like a list, but it's something that cannot be changed. So to illustrate this, let's say I want to create a people dictionary, and I want my key to be Isaac and Newton. I don't want it to be the same string. I want to be able to distinguish between first names and last names, say. So let's start it out like this, and we see that this list is an unhashable type, so we just can't use it. So the syntax for a tuple is open parenthesis. It's parentheses. And so in this case, we can do Isaac Newton and set that to be 1602, and let's go ahead and set an entry in our dictionary for Charles Darwin as being 1809, and that should be fine. Great. You can destructure a tuple in the heading of a for loop, which can be useful. So for example, for, let's name the first element of the tuple first and the last element last, second element. For first, last in people, let's print out first, and let's say was born in, we'll get it their birthday by going to the index of people and giving it the key of first and last. Isaac was born in 1602, Charles was born in 1809. Great. So as an example, let's create a histogram. Let's create these numbers. It's going to be a list 1 0 1 2 0 0 1 2 1 3 0 2. Okay. And we're going to count these. So what I'll do is I'll create this count dictionary, and for n in numbers, if n is not in count, remember dictionaries are sets with value for each set member, so when you iterate over a dictionary, you by default get the key names. So if n is not in count, then let's set the count of n to be equal to 1. Otherwise, let's set the count of n to be equal to what's currently there, plus 1. Finally, let's print the count. can see we have 5 ones, 4 zeros, 3 twos, and 1 3. Great. So things like this that you think maybe should be easy or you shouldn't have to write out, you're probably right. There are lots of useful Python libraries, especially the standard library that comes with Python. So in this case, if I had a problem like this, I would just go to the collections module in the standard library, and I would import a counter. And I would simply create a counter out of this collection of numbers. And I would get exactly what I want. Now this is a counter object, but we can also cast it to standard dictionary. So we get the exact output that we had before. Okay. Another example. Keys are often strings. You'll encounter this a lot with materials project data. And in general, anything you get from the web, often your keys from the dictionaries you get back are strings. You would have to convert them. So for example, atomic numbers. Hydrogen is 1, helium is 2, etc., etc. Let's go up to boron. So if we want the atomic number of lithium, we just look it up in the dictionary that we created. We happen to have included in your notebook a little data library. So we have a dictionary of atomic numbers, just like we've done above. Let's do some example iteration from that. So for element in the tuple H, C, and O, I could have made this a list. I chose to make it a tuple. So rather than a variable that's a list or a tuple, I'm just inline creating one. So for each element in this collection, I want to print out that the atomic number of element is atomic numbers element. Great. So as we've learned earlier, you can iterate over the keys of a dictionary. So I'm going to set n equal to 0, and I'll say for element in atomic numbers, if n is less than 5, print the element. And let's use this little shorthand for increasing the value of n. I'm just using this n so the page doesn't scroll down for every element, and we just print out a few of them. Now, we can also iterate over key value tuples of a dictionary using the items method. So let's redo this again. And let's use our destructuring notation. So for element, atomic number in atomic numbers dot items, and this doesn't create a copy, so you have a very large list. It won't create a new thing. It just sort of returns one at a time, which is very nice for performance. And let's do the same little thing. So we just print out the first 5, and we'll just print out the element and the atomic number. And we get the same output, but now we have atomic number, so that's good. Okay, an exercise. How heavy is this molecule? You're given two things. One, a dictionary mapping atomic symbols to atomic weights. And I'll just load that right here from MP Workshop, data, import atomic weights. So for example, the atomic weights of, that's the atomic weight of lithium. And you're given a list of atom symbol and count pairs for a molecule. So for example, here are some example molecules. Methane would be 1 carbon and 4 hydrogens. And aminothiazole is this little list right here. So you need to come up with a little program using everything that we've learned in this lesson to print out the molecule's molecular weight. Go ahead and pause the video and then we'll walk through it. Okay, so I know from tables that the the molecular weight of methane is 16.0423, and I know that that of this molecule is 100 or about that. So let's pick a molecule to test. Let's say our molecule is going to be methane, and we will go ahead and do stuff to calculate the molecular weight. So it looks like for element and count in molecule, so we actually want to accumulate this. So let's say weight is equal to 0, and let's see, I want to get the atomic weights, the atomic weight of the element, and I want to multiply it by however many I have in this molecule, and I want to add that to my weight. And I want to do that for every element and count I have in the molecule. Great. So that's the value for methane. Let me go back and copy and paste this there, and let's see if I get the value I expect. Great. So now you've learned how to work with sets and dictionaries and enumerating over them. They're very simple but powerful data structures that you can use in your work, and you'll be getting a lot of your data from the materials project in the form of lists of dictionaries. So it's very useful to be able to know these basics in Python.